For physics, you only have to know about 7 different derivatives. The first of which is the power rule, and generally we write it like this: if f of x equals x to the n power, f prime of x equals nx to the n minus 1 power. This can also be written using Leibniz notation, and instead of f of x equals x to the n power, we could write y equals x to the n, and this is my favorite notation because it allows us to use Leibniz's little pun on dy dx is nx to the n minus 1 power. I want to just remind you of stuff from algebra about the power rule. Remember, if you have f of x equals square root of x, that is the same as x to the 1/2 power. Also, and then you can use the power rule just like before. And if you have x on the bottom of a fraction and it's just 1 over x, or maybe it's 1 over x squared, that is the same as x to the minus 2 power, and then you can use power rule with n equals minus 2. The next function I want to talk about is f of x equals sine of x, and rather than doing a mathematical derivation, I'm just going to briefly sketch out what the slope of this function looks like. So I'm going to make a graph of the slope of this function. And so you can see right here at the beginning, the slope is kind of steeply positive. So I'm going to say, oh, the slope right here, which is kind of steep, that goes here. And then as we go to the right on the axis, the slope, notice, gets less and less positive. And so what I'm doing is I'm going to make a graph of the slope of this graph. So here it's less positive. So the slope of this graph is less high on the y-axis. And then if I go on, the slope right here is going to be 0. So here I've got the graph of the slope at y equals 0. So, and if I go on, notice right here and here, the slope turns negative, and it's getting more and more negative. This is like steeper in the negative direction. So what I have is there should actually be probably a dot right here. But if I go on, notice the slope gets less and less negative here. So I have a less negative dot for my slope, and then finally I have, once again, right here the slope is 0, and so I get back to 0, and I think you can see where this graph is going. If I make a graph, so down here at the bottom I have a graph of the slope of sine of x, and notice this is a familiar graph. You should recognize it from algebra. And so we know that the derivative of sine of x is equal to cosine of x. Now, something intriguing happens when we look at f of x equals cosine x, and I'm going to do the same thing. I'm going to draw the slope, and I'm going to make a little graph of the slope of f of x equals cosine x, and here, right at the beginning, the slope starts out at 0. So I'm going to make my little graph starting out at 0. But interestingly enough, as soon as I go to the right, the slope is negative. And so on my little graph, the slope here I'm going to enter is got to be a negative value, because right here the slope is negative, and this graph says, oh, let's say the slope is minus 2 or minus 1, and so I have to enter a minus 1 in. So this has to be below the graph when I graph the slope. And if I go a little farther right, the slope gets slightly more negative. So I have to enter a little data point that's slightly more negative, and you can see where this is going. If I go farther to the right, the slope goes back to 0, and I'm going to enter my 0 point, and you can see how this graph goes. It starts going positive again, And in fact, what we have is another kind of familiar graph, but it's interesting. What we have is not a sine graph. The graph of the slope of cosine of x is an upside down sine graph. In fact, the derivative of cosine of x is minus sine x, and that's just how it is. When we look at a picture of the slopes of cosine x, they turn negative right away, and they don't get positive till the end here. And what that is it's minus sine of x. So what I want to leave you with, even though the derivative of f of x equals sine of x is positive cosine of x, the derivative of f of x equals cosine of x is minus sine x, and that's just how it works out graphically. It's not symmetrical. The derivative of sine x is positive cosine x, but the derivative of cosine x is negative sine x. That's just how the graph comes out. The next function I want to tell you about is e to the x. But first I want to tell you about the number e. Now, e is a very special number, and I don't think it was invented for calculus. I think it has to do with some kind of compound interest rates, which are used for not calculus all the time. But I want to give you, e is a number, and it's a special number. But in order for me to tell you all about the number e, I have to tell you two things about Andrew Jackson. So I'm going to tell you two things about Andrew Jackson. So if you want to know what e as a number is, you have to know two things about Andrew Jackson. So there are two things about Andrew Jackson. And Andrew Jackson was the 7th President of the United States. Andrew Jackson was the 7th President of the United States. And Andrew Jackson was inaugurated in 1828. His inauguration was 1828. So you should write 1828. And Andrew Jackson served 2 terms of office, and so you write 1828 twice. And in the White House, there's a picture of Andrew Jackson, and in this picture of Andrew Jackson, the angles are 45, 90, and 45. 45, 90, and 45. And that is the number e. And you got to know stuff about Andrew Jackson to fully appreciate number e. Actually, the number e goes on forever. It's an irrational number. But this is a special number, and I'll tell you why. Here's the graph of f of x equals e to the x, and you can see right here where x equals 0, e to the 0 power is 1, y equals 1. And the more and more negative x goes, x has to be negative infinity, so way to the left on the x-axis, this graph is going to be 0, but it's not 0 until x equals negative infinity. And it's an asymptotic approach to the x-axis as you go left on the x-axis, and it gradually increases, so right when it gets to 0 on the x-axis, the y value is 1, and then it increases faster and faster. But the interesting thing about if you were actually to plot the graph of this, plot the slope of this graph, so on the left it asymptotically approaches a horizontal line, it gets more and more. Turns out, interestingly enough, right here, the slope of this graph is in fact 1. And if you graphed the slope of e to the x, it would look like this. This is the slope of e to the x, and it looks exactly like e to the x. And this is the only time it happens ever, I think this is the only time that happens ever, that a graph of the slope of e to the x looks exactly the same as e to the x. Isn't that weird? That's just weird. But anyway, what you have to know is that means the derivative of e to the x is also equal to e to the x. That's like strange. So what that says is the slope of this graph is itself. The equation for the slope of e to the x is, in fact, e to the x. Isn't that strange? And interestingly enough, e is a number used not just in calculus, it's used in all kinds of accounting and financial math. But the important thing for calculus is that the derivative of e to the x is also e to the x, and that's just cool. All right, the last equation that you have to know for AP Physics is natural log of x. You might have seen the ln button on your calculator. That stands for natural log of x. All you really need to know is it's just a button on your calculator. If you remember logarithms and natural logs from Algebra 2, that's what that button does. But I will just tell you, and it's important actually for integral calculus. It's not really that much used in differential calculus, only it's just another equation that we know the slope of. It turns out that the slope of natural log of x happens to be 1 over x, and it has more importance. When we get to chapter 7, we'll come back to this in the second part of calculus, which is integral calculus. But for now, all you just have to know, if you are given an equation that says natural log of x, the derivative is 1 over x. Next, I want to tell you about what to do with combinations of any of the 5 previous equations. And the first thing I want to tell you about, what if there's some constant out in front? So let's say the equation in calculus we use function notation, and generally k is any constant. So k is going to be like 1, 2, or 3, or 3.5, something like that. It's a constant. It's going to be a number. And so this could be f of x equals k times g of x, and that, for example, that could mean f of x equals 4x squared. So in our example, this k is 4, and our function g of x is x squared. And how we treat this if we have a constant out in front of one of our 5 equations is we just leave the constant where it is. And then we take the derivative normally. So how we would write this in calculus notation, we would write f prime of x equals k times g prime of x. And what that means is whoops, I want an arrow. So what that means is we're going to leave the constant here, and we just take the derivative of this function. And so the derivative of x squared is 2x. That's from the power rule. So notice that all that I've done is the derivative of this function, the k is in the same place, it's out in front, it just stays there, and whatever my function is, I just take the derivative of this. So notice the k here is out in front, it just stays there, and the derivative of x squared is 2x. And then if I want to, I can write that 4 times 2 is 8x. Alright, and that's how you treat, if there's any one of our 5 equations that we know the derivative of that we went over just now, and there's like a number out in front, what you do is you just leave the number where it is, and then you just take the derivative of the function itself, and at the end you multiply 4 times 2, and that's going to be the answer. That's going to be the answer. The derivative of 4x squared is going to be 8x. So what happens if you have a bunch of equations just added to each other? For example, how we write that in function notation is f of x equals g of x plus h of x plus j of x, for instance. And so that could be f of x equals x cubed plus x squared plus x. So those are all functions, and they're just added together. And if you want to find out the derivative of a bunch of equations just added together, it's kind of obvious. You just take the derivative of each of the equations individually, and you just add them together. So that would be g prime of x plus h prime of x plus j prime of x, and all that is you take the derivative of each function separately, and at the end you just add it together. So in our example, we would have f prime of x here is just the derivative of this plus the derivative of this plus the derivative of this. And the derivative of x cubed from the power rule is 3x squared, and I just add it to the derivative of x squared, which is 2x, and I just add it to the derivative of x, which I know is 1. So notice if you have any, now, and it doesn't have to be, this time I just have to pick x cubed as a function, this is x squared as a function. It could be anyone. This could have been sine of x, this could have been e to the x. But so if you have any of the functions that we've covered just added together, then you just take the derivative of each one and you add them together. Oh, incidentally, what if it was minus, if one of them was subtracted, you just leave that minus in. I guess it doesn't have to be added. Some of them could be subtracted. But any of the functions that you have, if they're just added together, then you just take the derivatives separately, and that's actually the answer. Isn't that interesting that the slope of this equation, you just take the slopes to find that, you just take the slopes of each individual equations and add them together, and it's the slope of the whole equation. That's kind of interesting. Here's what you do if you have two equations times one another. So let's say you have f of x equals g of x times h of x. So this is one of our equations times another of our equations. And the derivative of the product of two functions is you take the derivative of the second function, leave the first function unchanged, and you just take the derivative of the second function, multiply them together, and then you take the second function, leave that unchanged, and you take the derivative of the first function, multiply those two together, and add them together. And alright, so for example, let me make these a little smaller so we can have them. Alright, so let's say that f of x, for example, equals x squared times sine of x. Alright, so one function, this is going to be g of x, and this is going to be h of x. So in order to take my derivative, f prime of x, I take the first function, x squared, and leave it just as it is, x squared. And then I take the derivative of the second function, and I know that the derivative of sine of x is cosine of x. And then I add it to the second function just by itself unchanged, sine of x, and then I multiply that times the derivative of the first function, and so that's this derivative of the first function. And the derivative of x squared, is also known as 2x. Now usually you should rearrange the sine x for some reason in math. I don't know. Always goes at the end of the function. So how you'd usually write this is equal to x squared cosine x plus 2x sine x. That's how you would usually write that. If there's two equations multiplied together, you could rearrange. However, In physics, you should simplify as little as possible, especially for this calculus. When you're doing the calculus homework, don't simplify at all. You could just it's totally okay to leave this as it is. Although if it's a multiple choice question, I'll probably write this way out of habit, and you'll just have to know those two are rearranged. And in calculus, I'm pretty sure you're going to have to you'll get marked off for leaving your answer like this. But in physics, you usually won't get marked off. And the only time you'll have to know that is if there's a multiple choice question. Just be aware, not to be confused. It's sometimes these two are the same essentially. It's just tradition that the x's go in front of the sign of x's. Oh, by the way, I forgot to mention that when you have the one equation times the other equation like we just did, that's called the product rule in calculus, because when you have a product of two functions, that's what you do. You do this. This is the product rule, and you should just know that by name. So if I say, oh, for this problem you have to use the product rule, that means you're using this little statement. But like you take one equation, you leave it unchanged, take the derivative of the second equation, and then you take the second equation, leave it unchanged, and you multiply it by the derivative of the first equation, and you just add those two together, and that's the product rule. The next rule is the quotient rule, and this is where you have one equation divided by another equation. And the quotient rule is kind of long. If g of x is the top equation and h of x is the bottom equation in a division sign, it's this long equation. What you do is you take the bottom equation, leave it unchanged, then take the derivative of the top equation, multiply them together, and then you subtract off the top equation unchanged times the derivative of the bottom equation, and then you divide it by the bottom of the equation squared. The original bottom equation just squared. All right, and notice it matters because of this negative sign. It matters what order, which of these go first. Notice it's the bottom equation not derived times the top equation derived. That goes first because the top equation not derived times the bottom equation derived, that's going to be a negative sign. And if you get those backwards, you get the wrong answer by -1. So there's a rhyme, there's a mnemonic that helps you remember that. If you remember the top equation as the high equation and the bottom equation as the low equation, and D stands for derivative, here's the rhyme. It goes low d high minus high d low, square the bottom, and away we go. And you have to say square the bottom and away we go because it rhymes with high d low. So here's the rhyme: low d high minus high d low, square the bottom and away we go. And that's how you remember the quotient rule. Alright, for example, let's say we have x squared divided by sine x. So this x squared is g of x, also known as high. Sine x is h of x, also known as low. And in order to find the derivative of x squared divided by sine x, what I have to do is I have to say low d high, which is sine x unchanged, times d high, which is derivative of x squared. So derivative of x squared is 2x minus high d low. So my high is x squared, so that's going to be unchanged. And high d low, low is sine x, derivative of sine x is cosine x. So x squared times cosine of x. Square the bottom and away we go. So the bottom equation is sine x, and I just square it. And so that is the derivative of x squared divided by sine x. And sometimes I'll write this 2x out in front of the sine x, but when you're doing your calculus homework in physics, don't bother doing that. Don't simplify it all. The last rule we're going to go over in AP Physics is chain rule, and this is also known as the composition function. And this is where you have one equation inside of another equation, and then we have to use the chain rule. And what you do, if you have one equation inside of another equation, what you do is you take the derivative of the outside of the equation and leave the inside equation unchanged, but then at the end you multiply by the derivative of the inside of the equation. That's kind of confusing when I write it out like this, but it's a little more easy to understand if you see an example. So let's say we have f of x equals sine of x quantity cubed. Now this is also more commonly written as f of x equals sine cubed of x. That's how you usually see it in a math book, but really sine cubed of x written like this really means parentheses sine of x inside parentheses cubed. So here you can see what I mean of one equation inside of another equation, and here this is one equation. The h of x is, that equation is sine of x, and that's inside g of x, and the inside g of x is actually the outside equation is really parentheses x cubed. So the outside equation is really x cubed. And so how chain rule goes is I just take the derivative of x cubed, this is the outside equation, parentheses cubed instead of x cubed. The derivative of that, I leave the inside equation unchanged, and then I'm going to multiply by the derivative of sine of x. So how you should think about it is you're taking the derivative of x cubed, and so when you want to take the derivative of the outside equation, you're going to do f prime of x equals 3 times parentheses, that's parentheses, and then x squared. The derivative of x cubed is just 3x squared, so the derivative of parentheses cubed is 3 times parentheses squared, and what's inside the parentheses is just sine x, and that's unchanged. So this is the derivative of the outside equation, but then I have to multiply by the derivative of the inside equation, and the derivative of the inside equation, the derivative of sine of x, is cosine of x. And that's how you do the product rule. So it's kind of hard to spot that, sine of x sine of x parentheses cubed is an equation inside of another equation, and you have to know that the outside equation is really x cubed in that case. Alright, another common case where you have to use chain rule is with if there's an equation inside a square root sign. And if you have a square root sign, you just have to remember that really f of x, you don't think of it for calculus, you don't think of a square root sign as square root of cosine of x. What you should think about is cosine of x. Whenever you see a square root sign, you should think of to the 1/2 power. Okay? So now we can see that the outside of equation is parentheses to the 1/2 power. And if I want to take the derivative of that, that's going to be 1/2 parentheses to the 1/2 minus 1, or also known as minus 1/2 power. the inside equation stays unchanged, cosine of x, but then I'm going to multiply by the derivative of the inside equation. So the derivative of the inside equation is minus sine of x. Right? So there's another example of chain rule. And you could simplify, and I think if you get this type of problem on the quiz, it's a little bit simplified. Like I'll move this minus side out to the front. I think that's as much as I'll simplify. I won't simplify very much. You don't have to simplify on your homework, and the only time it might be confusing if it's a multiple choice test and my answer is a simplified form. Hopefully I'll avoid that on the test. Alright, and so those are all the calculus rules that you need to know for AP Physics until Chapter 7.